So now in order to look at the FFT, I am going to hide the crowd again. And if I display the texture and the waveform, and I make sure that the audio analyzer now looks at the FFT, and if I play, so it's very hard to see anything happening on the texture, but we can see something happening on the line. So let's focus on that for the moment. And if we come closer, we can see basically that we have some frequencies that are having some energy in the low frequency, but almost nothing in the high frequency. And so I'm simply going to increase the range here to see that makes a difference. It does not. Maybe if I put this, that's going to move it down. So maybe I should actually look at what the positional audio shows me. And the range is a little obscure. So what I'm going to do in that case, I'm going to toggle off normal range so that I have much different ranges. So here I go from -500 to -30. So let's go from -200 to 0. And yes, we have something that is much more visible, even on the actual texture. So what I'm going to do now is I'm going to actually not use those notes anymore, but I'm going to use an audio file. So what I have here is I copied an audio file into the public folder of my project. And once I've done that, I can browse from a file node and select it here. And now that I have that, I can play the sound. So now, and we can see that here we cannot use the piano anymore. The controls we have to, if I stop this, the control we have to pause and play the music are those controls, and the volume. One thing we have as well, because right now what's going to happen is the music might be over my voice, so I can still find a way to play it and affect the analyzer nodes and make sure the music does not cover my voice, and it is by going into the Windows root node params, and from here we can say, if I make this a little wider, display audio icon. And if I plug this, and we have an icon here that is black over black, so not very visible, but I can put it on white. And now if I play, I can make sure that the sound is not actually being broadcast out of the browser while still affecting the analyzers. So now we can see what a music that is symphonic music that does not have strong beats is doing. And so now once we see that, the question is, okay, how do we use that to affect particles? How do we use that to detect bits? How do we trigger events based on a certain moment in the music? And the question is, in my experience at least, having tried different things, when the frequencies are so, when there are so many frequencies, I found it very hard to do anything. The way I found to extract meaningful information from that is to group each of those frequencies by octaves. And what I learned while doing that is we have the first few numbers in the array that is written by the FFT is 1 octave, then we take twice more that number, that's another octave, and then again twice more that number, that's another octave, until 1/2 of those frequencies being the last octaves. And once we have that, once we have grouped those frequencies that way, it's much easier to, first thing is we're going to have less of them, and the second thing is going to be much easier to detect event and to apply them to something else in the scene. So that grouping happens when you click on as octave, and that's what it looks like. So now I can normalize that, and I want to have -1, 2, 1, I think. And now this is what I can see. And that is much easier to deal with. Right now, I think the music is at a low point, but what I want to do is actually restart it. And we're going to see that if I increase the volume, we have strong events relatively quickly. What I want to do as well, instead of having to go here and click every time, I want to tie some events to it. So I'm going to create an events node. I want to make sure that whenever I go back, pause and play, the music restarts, and that will help me just fine-tune things without having to have too many buttons scattered on the UI. So I just want to have a scene event, and when we click play, then we are going to click on a specific parameter, which is in that case this restart parameter. And I pass the path and I play here. That should do. And I do say it's actually a button. So now if I play, the music starts playing. And so I don't need to fiddle with those buttons anymore. So now we have that. Let's use the waveform to find a way to trigger when the frequency changes quickly. And that's where this, actually I just see the texture, but I should not. That's where this texture, the second line of this texture comes into play. So what we have here actually is so this first line is what gives us this information. The second line is the speed of change, how quickly those volumes are changing. And that's what we're going to use. So basically I don't want to use how high a value is, although that can come in handy to control how big an impulse is. But in order to know when an impulse needs to be triggered, we need to look at how fast the music changes. So what we are going to do here is, actually I can display that speed here just by looking at the UVs. Instead of being at the 0 on the V of the UVs, we can be in that place, and that is this part here. So that's our speed. Now, I might be confused in the sense that it might be the other way around. I'm just not sure, but this is definitely the speed now when I have a dit number, and this is the raw value that the FFT gives me. So now that we know that, what I can do is say, okay, when this value is above a certain number, I'm going to trigger something. So let's do a compare when we are above a certain number, and we're going to trigger that later. Then something happens. If we are not, something else happens. So in that case, I will simply keep it at 1 or 0. So if I display that here, you can see that too much is happening. So if I increase this value, now we have some spikes happening a little less frequently, maybe still a bit too much depending on what we want to do with it, but we have a sense that we are triggering events. I'm going to actually use that same value here. So now we go from this to that. And now, in order to make that a bit clearer, I think I'm going to have two lines. We're going to have one line that displays us the FFT as it is, and the second line displays us how we filter that information. So I'm just copy pasting that. and I can actually reformat that a little bit. So I just need one line. One will have one material. I'm actually going to display the material. I'm going to apply a row value, and this one is going to be the speed. So I'm going to have one material here, one material here. I can delete that. One transform here, and a merge. So now I'm seeing both lines. Let's I will put a constant for the color. Let's keep the default one in white, and I'm going to have the speed in purple. Now I need to assign it like this. Speed. Okay, so and let me put this back to the row value, and I'm going to hide the texture for now. It's a bit distracting, and so if I go back to the value, I need to actually display the right UV. So this is my FFT, and that's how we filter that information. And that might be the right, we might already have that correctly, but it's good to be able to compare them visually. We're probably going to come back to that as we apply that to particles. And so let's now start setting up our particle system, and we're going to see how to use that to apply forces to the particles. So let's start and set up the particle system. So I'm going to hide this. I'm going to create a new geometry. Let's call that particles, if I can spell. Particles. Let's create, I can get rid of all those pop-ups. Let's create a sphere, and I'm going to change the background color for now to see something. And I'm going to scatter some points for the moment, and I'm going to create a particle system. Now if I simply go inside and create an add node, and I'm going to increase, then the particles are moving. So let's make that a little nicer. I would like to have another sphere inside, just so I can see this, those spheres by contrast. I'm going to make that a little smaller, and it's quite black already, but I'm going to make sure it remains black if I add a light. So just want to have a mesh basic black color, and I'm going to assign it here. That's just to give some contrast, so that we don't see through the particles. Let's call that black sphere. And I don't want the particles to be those squares, so I'm actually going to have other small spheres. I'm going to create an instance. I'm going to make that very small, and now the spheres are not displaying because I need to add the I need to change the material. The material that is for the instances is a mesh material, whereas the material that was automatically created when I create the particle node is a point material, which doesn't work if I use instances. So I'm going to recreate, I'm going to make a copy of that one and call that particles. And I'm going to assign it particles, and we have now the particles displaying. And actually I don't want, I do not want a Lambert, I want a basic, so I'm going to redo the same thing, mesh basic builder. That is going to be my particles. And I'm going to take what's inside here and replace it. Replace those two nodes like this. And I can delete that one. And I'm going to reassign the material here. Particles, mat, mesh basic builder. Good, that's what I wanted to have. Now, I am not so sure that is a distribution of point I want to start with. I'm going to use instead an icosahedron. It is a little nicer, and if I make it denser, I will start with this type of distribution. I made it a little smaller as well. So that is going to be the starting point of my particles. And if I press play, nothing happens. Because now this particle system is using the position to it will update the position attribute of the input geometry, but since we are using instances actually use the instance position attribute instead, so that's what I should update here. I should make sure that the particle system does not use position but use instance position instead. So I will create an attribute node, that's fine, and I will create one to read from and create one to write to. So the one we read from is going to be here like this, the one we write to is going to be the same thing, except I need to toggle export when connected. So here we go, and I will keep that for now. So now the points are moving up again. So let's continue adding some forces to this particle system. So I want several things. Before adding the impulse from the FFT, I want to make sure that whatever force I'm going to apply to the particles are going to come back to their own position, otherwise things will keep blowing up and a single impulse will just scatter points everywhere and we're not going to be able to see the further impulses. So let's simply apply one dummy impulse for now. So I'm going to use the time to say, okay, when we are below that time, apply a force. When we are after that, do not apply a force, and make sure that the particles come back to their original position. So we have this two-way switch. When we are below that time, we're going to apply a force that will have this value, this speed or amount of force, and I'm going to use the instance position itself as the direction of the force. So each particle will go, particles that are here will go this way, particles which are here will go that way. And so the first thing is how to apply a force. So we have the acceleration node, which basically derivates the position and velocity based on an input force. So the input is going to be my position, that's this. The velocity is going to be the one from the global node here, and I plug those back here and here. So now if I do not do anything, particles fall because we have a default force of minus 9.8, which is the default gravity. And if we want to apply a force that is going outward, I can use this as a force. I can simply plug the position and now particles should go all outward. Now if I don't want this force to be applied all the time, I'm going to multiply it by whatever we have here. So I'm going to write a mult scalar. We have this here and here. So now the force was only applied once, but since there is no break, particles keep going outward. So I will still try, before adding the force that pulls them back, I will apply a drag. All I need to do here is multiply this input velocity by a certain number, which is slightly below 1. So just multiplying it by 0.98 should help break. So we go a little out, and then the particles speed diminishes slowly, and then they finally stop. So if I multiply the input value, they go a bit further, and then they stop. But they don't yet come back together, which is what we want to do. So we want to have a force, let's say for that particular is here, that pulls it back to wherever it was initially. In order to do that, we need to know where it was initially, so we need to store that information. And we are going to store that in an attribute. So from here, we are going to create an attribute, the rest attribute will do just that. Rest attribute is going to add rest n and rest p. In that case, we don't need rest n, so we are just going to store rest p. And rest p is the same thing as a position, except that unlike the actual position, which will be updated on every frame, rest p will not be updated, so we can always rely on it to get back to where we were when the simulation started. So I can import it here. And actually, before importing it, I need to make sure that it is propagated until the particle system. And when I middle click on the instance node, resp has disappeared, it's not propagated. So I need to make sure that the instance node does propagate it into the instance. So now if I middle click, I have my resp here. And now I can use it in the particle system. So if I read it here, it is a vector 3. And now I want to have, so whenever a particle is here, at let's say here, I want to have the vector that goes from the current point position to rest p. And in order to do that, I need to subtract the instance position from rest p, or subtract rest p from the rest position, the other way around, whichever way it is. It might be, I will try one way and I might have to subtract the other way, I never know. And I give that to this mult scalar. So now if I do that, no, I do not do that, that is incorrect, so that remains how it is. This force that goes outward remains what it was before, but I'm going to add a second force, which is going to be the opposite force which we have created now. So now we have those two forces which are going to be added into the simulation. And that's what happened. I got the other way around, so I can select that node, press Shift R, and it will invert the inputs. So now I have that, and here we are. So we have at the very beginning this impulse which pushes the particles outward, and then that force which is always active, which pushes the points back to where they were. And now that we have that, we can start applying the force that will be created by the FFT node. So now what I'm going to do is go back into the waveform material that we had here, and I'm actually going to display that slightly on the side, or maybe I'm going to display it above our particles. and I'm gonna try and use them like this. So I want to use the same system that takes the that gets the triggers out of the FFT into the particles. So I will go into this material, and what I'm interested is that. So I'm copying that, going back into the particles here, and I want to use this like that. Now I need to link the texture. Not that I have copied this texture node, copy pasted this texture node. I also have this texture param that has been created, and I can link to this texture. Now whatever value comes out of here is something I want to multiply by that's what is the impulse. So the dummy impulse I was using here is actually what I want to put here. So I'm going to link this value right here. Now what I am missing is the value that what our proxy UV that we feed into the texture. At the moment I have the PTI attribute, which is not something I have yet on those particles. So I will need to have that, and I think from the icosahedron I can probably use the UVs, yes. So in that case I will actually use proper UVs, and if I check that they are propagated, I have the UVs that come here are converted to the instance UV. So I will use that. So I create an attribute, and do I have it as a preset? No, I do not. Instance UV. I just want to make sure I'm spelling that correctly. It is a lowercase v. So I go here like this. It is a vector 2, and I do not want to use both U and V. The V is still what will allow me to decide if I use the row FFT or the second row of the texture, which is going to be the speed. So I will only use the U and not the V. So I convert the vector 2 to a float, and I will plug this here like that. And I keep this value at 0.7 something, anything between 0.5 and 1, so that I can use the row on the texture that is the speed of change. Now that I have that, let's see what happens. Not a lot happens. To double check, I want to make sure that this new input has enough strength to not be immediately compensated by the force that will bring the particles back. So for a test, I will simply bypass this and only use the impulse that push the particle outward. So if I play this, if I come closer, that's where I should see an effect. I do not yet, so I want to make sure that this goes here, so I should have instance UV. So I'm going to double check before, so at every step I'm going to try and see if I apply the length of the UV, for instance, to the force, what happens? Yes, so it does work. So we have the particles going outward with an impulse based on that depends on their UVs. So that is correct. Let's try at this level. I'm assuming that will not change. That is still correct. The texture is here. That should be good. If I apply the value directly from the texture, let's see what happens. And here we seem to not have a lot happening. it is looking at the right texture. I'm looking at the right value. I'm going to multiply this value by something like 100. And yes, we start to have something. So that is correct. Now what I did not expect is it looks like the UV is actually, the U of the UVs goes on the longitude of the icosahedron, where I wanted it to be on the latitude. So I'm actually going to use here the V in here. And now, yes, I have different effects on that. The effect changes on the y-axis, which is what I wanted. So now what I'm saying is basically what happens on the, no, it is the speed level, it is at the speed, but it also takes into account the negative speed. And I also had to multiply this effect by a large value, otherwise nothing was happening. Probably because it keeps going positive and negative, so it tends to compensate itself. But if we were to only use the positive value when we filter them through here, then we may not need to multiply as much. But let's keep the multiplication for now and see what happens. So yes, that seems good. The effect is happening. We have, whenever we see a spike here or an impulse, then we have a force being triggered. So now I can put the other forces back. And let's see what we have. Yes, so we have the particles being pushed as our impulses are detected. And now that's the backbone, and from there is still a lot of tweaking to find out, okay, what numbers do we use? Do we need to have other forces? Do we need to add a noise here and there? There is still quite a few things to figure out, but let's try just play with the numbers for now. So I'm going to multiply that by 500 now, and we start to have something that makes a little more sense. What I very quickly don't like is that we have very distinct rows of particles, very distinct group. So what I want to do is add some randomness to it or some noise to it. So the instance UV that I have here, I want to try and find a way to not have such regular grouping. And one way to do that is to add a noise, and I'm going to use the instance position as the position of that noise, and I'm going to output not a vector but a float, and I'm going to simply add those two values together, and let's see how much that disrupt the shape we are looking at. That disrupted probably too much, so let's give it a very low amplitude. But yes, that's already less regular. Now the other thing that I am not a fan of is particles only move outward and back, and that's it. They move along a single line. So we need to add another noise into this. So now if you're at that stage of the tutorial, you probably want to hear the sound as you work, because it's so much more inspiring to know how much strength each moment has when you can hear the music. When all you have is this graph that is not allowed to really choreograph the particle to decide, okay, how often do you want to allow the triggers to happen. So that's something I will leave to you, but I will have to keep that off for the moment in order to record this. So if we go back to the noise I want to apply, so what I will probably do as well is put that into a subnet by pressing Shift C after selecting all the nodes and checking that it still works. Yes, that will just make things a little clearer, and I can always go back into this and keep editing it. And so now let's try and add a noise that will also add to this force. So I'm creating this noise. The position of the noise will still be the instance position, and let's add it like this for now and see what happens. So that's probably a little over the place. It does add some organic feel to it, so that's good, but it's all over the place. So what we should probably do is have that noise multiplied by this. So what I can probably have it as the amplitude here. So if I have a float 2 of x3, I can put this like that, and let's try and have that. So now whenever the particles are pushed outward, then they're not in a straight line, but it does have some life to it and things get a little messier. And that is probably the most of the what you would have to do to have a particle system driven by a music. One thing we can look at as well is just making those particles a little nicer. We can add some colors to them, we can make them stretched when they are going fast, but you already should have enough to play around and use all those three analyzers, emitter, waveform and FFT, and create something nice with it. But let me keep going and add a bit more polish to this. So now if I go out of the particle system but go into the material, so we have those nodes, and if we were to add some colors to it, so we can plug anything into this, so I could let's see if I have a unique ID. I do not have a unique ID for those, so let me create that. Attribute create. I'm going to use a preset, PTI again. In that case, make sure it is passed through the instances. It is not yet. PTI, I created here. Now I have it here, so I should be able to read that in the material. Attribute PTI, and if I put that into a random, after converting it to a vector 2, float to vector 2, and now if I put that into an HSV to RGB, first I'm going to convert that to vector 3, float to vector 3. They will be black because I need to increase those values here. That should do, except that I have all those colors, probably because I think it is in the fragment some precision error, so I think if I multiply this by, let's say, 1000 and I make a round, that does not quite help. Oh, I know what happens. What happens is that there is an overlap of points that we have from the icosahedron. There are several points on top of each other, so I need to have a fuse here. So here we have 6,000 points, So if I see them like that, and here now we have 6 points, that is not enough. If I reduce, I do not see the points easily. I'm going to apply a delete here just to keep the points. So I'm going to delete the object. I have no object, but I keep the points. So those are the points that are out of the icosahedron, but there are multiple on each of those dots. There are multiple points on top of each other. So if I do that, I'm going to apply the fuse after the delete. At the moment, the fuse does not quite work. The fuse is meant to fuse points which are within a specific distance from each other. It does not yet work on geometries, only on point clouds like this one. So I'm going to apply it here. So now it looks the same before, with or without the fuse. The difference is, on one case we have 6,000 points, and on the other case we have 1,000 points. So that should hopefully resolve, yes, the color issue we were having. Now I'm actually wondering, do I need to do that? Yes, this round still helps. There is an alternative to doing that. The one thing that's happening here is that we are reading an attribute from the geometry, and as the materials in Polygon.js abstract the fact that you have a fragment shader and a vertex shader and a fragment shader, sometimes by taking an attribute and writing to the color, you sort of bypass, the shader resolver will create a vertex shader that reads the value and pass it a bit too quickly to the fragment shader. But there is a way to control how that's done with the varying read and write. So here I can do the following. I can write as a varying attribute the actual color that I want. So I'm going to plug this here, make sure it is a vector 3, vector varying right color, and varying read color. Make sure the name is the same, that it is also a vector 3. And now if that goes into the color, that will solve the color interpolation. So we don't need to round this either. And that can stay on its own here. Now do we let's try and have the particles only become colorful once they are given energy by the particle system. So for that we need to use the velocity attribute. So attribute, is it on the preset? It is not. Velocity vector 3. And so what I want to do is I want to basically do a mix between white, like this, and this varying color based on the velocity speed. So if I take the length of that vector, and if I remap the length, so I'm going to remap it, we will see what values we have, and we're going to use a mix. So we're going to mix those two values using that. Now let's see what we have. Now we can see that as they are getting an impulse, they are picking up some colors. Now I'm tempted to think that it would be nice if we were to pick a bit more color, so we can adjust that. And what if let's try like this. Yeah, that's probably about right. What I'm wondering is they seem to flicker. So let me just put this here. They don't flicker here. I'm wondering if they change a little too much of colors. I'm wondering if I should whatever we have this, let's see. Okay, I'll probably need a bit more thought to figure out exactly how to avoid them going to white immediately. But let's carry on not trying to add some stretch to the particles when they are going fast. So that's something we're also going to use velocity for. But I'm going to affect the instance scale in that case. So if I, for instance, plug some vector 3 in here, and I can have them stretch. Now, how do we know which direction to have them stretch? The D is probably the right direction in that case, and so we can do something similar to this, or I can simply just use that. And so I can probably do a mult add as well, where I would pre-add 1 or post-add 1 and multiply it by a specific value, and that would become the Z component. So that goes here, and we will have 1 and 1 here. So let's see what happens with that. So they are not stretched here, and as they are picking up speed, they become stretched. It's probably a little too strong, so I can reduce that a little bit. And I think what happens on disorientation is that it is not necessarily tied to the velocity. They seem to be stretched, but they don't seem to quite follow, or maybe they do. Yeah, that's probably right. Otherwise, what could be done is to use the align vector, which would align, where I would be tempted to align this the initial vector to an up and use that here, but that may not work. That is probably better. Yeah. Now I want to go back to this and try and see if I can find. So if I move this, I think I want to say as soon as the let me try with a smooth step. So if I have the length of that and I use a smooth step here, yes, it works better. that works better. Now the problem that I am facing using this is that when the velocity is nil, then we don't get anything, and velocity is nil at the very first frame. So what I could try and do, and I have not done that before, is to create an attribute velocity. Attribute create velocity with a size of 3, and I will put the position p.x, p.y, p.z, lowercase y, and now make sure it is taken by the velocity. So yes, that makes things much better. Doesn't quite work at this level. Is that because no, that is working? Yeah, that is working. Although no, velocity should not be like this. It should definitely be 0. But if it is 0, then the alignment of the vector is not going to work. So maybe I can try and multiply it by a very small value. Yes, I think that looks better. So that is the main thing I wanted to show you in this tutorial. There is of course plenty more we could cover regarding how to add forces to particles and how to make interactions even more rich by having particles react to the mouse, for instance. But yeah, hopefully that will give you some pointers as to what you can do with WebGL, Polygon.js and music. Thank you for listening so far.